Hello everyone, my topic is the effective fusion factor in FPN for tiny object detection. First of all, let me introduce the tiny object detection briefly. The tiny person is a typical dataset of a tiny object detection. It has three characteristics. The first is the absolute size of the object is tiny. The second is the relative size of the object is tiny. And the third is the boundary of the object is not clear. The process of FPN aggregates the adjacent feature layers can be represented as the right formula. We define the fusion factor as the fusion ratio when fusing a feature of two adjacent layers in FPN. We have studied what affected the effectiveness of the fusion factor in 5 datasets from 4 aspects. The final conclusion is that absolute size of the objects affect the effectiveness of the fusion factor. To further explore how to get an effective fusion factor, we design 4 kinds of fusion factor and conduct the experiment on tiny person. First is a brute force solution. The second is a learnable manner. The third is an attention-based method. The fourth is the statistic-based solution. The framework, this is the framework of our method. The box on the left shows the calculation of the NPI, and the right boxes and the right points represent the anchor boxes and the anchor points. Yellow box and the blue box are ground truths. The dotted box on the right is the framework of original FPN. Consider the performance and the practicality. S alpha is the best way to achieve a fusion factor. We further discuss whether the fusion factor could be learned implicitly. First, we analyze the structure of the FPN and find an equivalent realization of the fusion factor during the initialization. Secondly, we analyze whether larger datasets could be propel FPN to implicitly learn the fusion factor. We argue that the network possesses the ability to learn fusion factor latently when training dataset is large enough. We then discuss the mathematical fundamentals of a fusion factor from perspective of a gradient propagation. We have achieved performance improvements comparable to other detectors. The other experiment results demonstrate that the effective of our method and under different conditions include different detectors, different backbones, and the different datasets. In the future, we will extend our method to other scale datasets and the other difficult object detection tasks. That's all. Thank you very much. Thank you.